Some people may make fun of you for not knowing the relation of elements to their position on the periodic table. But hey, it's really not that hard once you get the hang of it. The number at the top of each element symbolizes the number of protons in that element. This is also called the atomic number. If you haven't realized, the periodic table is numerically organized by this atomic number. The number at the bottom of each element symbolizes the atomic mass. This is the number of protons and neutrons combined. There is no classification for this. However, the most basic way to classify an element is by its metallic properties. See this staircase? This symbolizes the semimetals. Semimetals are the dividing factor between metals and nonmetals. The semimetals display different characteristics under different conditions. Metals are good conductors of heat, take up 80% of the periodic table, and are usually solid. Nonmetals are poor conductors of heat and electricity, take up about 15% of the periodic table, and are usually gases. So the next time someone tries to make fun of you for not knowing the periodic table, simply say, "Oh yeah? Well, I can recite the periodic table backwards." But don't actually say that, unless you really can. They might want to take you up on that offer. Think before you speak. Both protons and neutrons are made up of smaller particles called quarks. There are a total of 6 possible quarks, with the flavors of top, bottom, strange, charm, up, and down. A proton has 2 up quarks and 1 down quark. A neutron has 2 down quarks and 1 up quark. But think of those lone little electrons that can't have quarks. Don't judge the electrons just because they're not quarky. The mole. Some people fear it, but don't be afraid. It's just a number that chemists use to take measurable samples of chemicals. 1 mole is equal to 6.02 times 10 to the 23rd particles. This number is commonly referred to as Avogadro's number. It was calculated using a carbon-12 atom. Therefore, 1 mole is equal to 12 grams in a carbon-12 atom. But in other substances, the mass of a mole depends on other atoms present. An atom's atomic mass is equal to its molar mass. So don't fear the mole. It's only